Hey everyone, welcome back to a new Latent Space Lightning Pod. This is Alessio, partner and CTO at Decibel, and I'm joined by my co-host this week, founder of Small AI.
Hey, and today we're very happy to have Sujay, who is co-founder CTO of Convex.
Co-founder and chief scientist, whatever that means.
So Convex, you've been on my radar for a long while because you have a really interesting sort of database and compute platform, which you're going to talk about in the second half of this chat. Jamie reached out to me specifically to talk about this new benchmark that you guys are working on.
Totally. So yeah, just, for context, Convex is like a competitor to Firebase. It's a reactive database. It's a database that's thought from first principles on what if we didn't have to use, MySQL and Postgres and the same things we've been doing for 30 plus years. What if we built something kind of like Firebase that was purpose built for full stack app development and made it as powerful and delightful as possible. And, over the journey of building Convex and, talking to users, we've seen in the past, 6 months, so many more users are writing code for Convex using all of the coding tools that have been taking off. And we've kind of been supporting people and cheering them on. And it's like in the past few months, we, given how much it's changed coding, we decided to just start to be a little bit more rigorous and start doing some experimentation and trying to be more quantitative and scientific about it. And the results are, pretty interesting.
Yeah. So I don't know if you want to kick off your screen share. We can probably get that up so people can take a look at it. I think so. Basically what you're saying, what I'm hearing from you is you did a bunch of evals on behalf of your user community, right? And also it's a way for you to benchmark yourself against the competition.
Yeah, totally. And so I think there's this kind of dream of having fully autonomous full stack app development is something that a bunch of users came to us a few months ago. And some of them are kind of running software consultancy startups where customers come in and then mostly using AI coding, build apps for them. Others are kind of doing stuff more in the bolt space where their users are coming up with prompts and then they're building a whole full stack app. Some of them are web, some of them are mobile. And so this is trying to make this more rigorous and something that we can run ourselves for the benefit of being able to reshape our platform to make it as amenable to autonomous vibe coding or AI coding, whatever you want to call it. So this is a post I just put out yesterday. And I think it's kind of one of the moments where we were running these experiments and my ears perked up a bit. And we'll kind of flip through this pretty quickly. But with this particular eval, we have the agent filling out the backend for a to-do app. So we kind of noticed that, stuff like V0 already generates front-end stuff quite well. So this is how can a model flesh out the data model, the network transport, the state management. And we're not going to have to wash through all of this, but it's pretty remarkable to just see that when it has the right feedback in Cursor Composer, and this was even on Claude 3.5, it can just autonomously code for 10 plus minutes and it can fix its own bugs. It can get to the point where it's pretty much a fully working app with just an initial prompt. And so being able to now reproduce this and see how changes to the platform or changes to the backend. This framework supports Convex, but we also compare it to Supabase and we compare it to a more traditional kind of 3-tier stack with Python, Fast AI and Redis, Fast API and Redis. And so that lets us kind of study what works well and what doesn't work.
One of the things we always highlight about Devin is, you have the code, you have the environment and all of that. What are some of the design decisions that you guys made here on what to expose to the models? You're not bringing people to code somewhere else. You're just letting them do this in their existing IDE. Did you ever think about building your own kind of all-in-one environment for people to work in or?
Yeah, I think some of it is, for this particular study, it's very manual still. And so I think I was just most familiar with Cursor Composer. So we have a standardized environment where we create the front-end app in Next and we set up authentication and we set up some user tables and stuff like that. And then we, from that starting point, kind of let Cursor Composer go off. I think, it's kind of that future work of, I would love to just be able to use Claude Code, use or even just make stuff more standardized where it's like running and, it's not just running on my laptop, it's running on a containerized environment I can do at scale.
Yeah, interesting. So you have three, I think if I scroll down on your benchmark here, you have three tasks, right? You've got the chat, you got the to-do, you got the files, and I think that's a pretty reasonable thing to start off. Obviously, you could do more than that. The three is a pretty good start. One exercise that, there are a couple exercises that I think come to mind. One is the 7 GUIs projects, which is a similar set of tasks that are supposed to fully circumscribe the common tasks that you do in front end. I think adding backends to that is a pretty interesting task. And then there's this old project run by Thinkster, who now runs Bolt, that does sort of real world comparisons. So like I think it's something like build a medium clone, but you swap out any front end, you swap out any backend. I don't know if that rings a bell. Well, anyway, that's really cool. So you have the 3 tasks, and then you also have the 3 backends that you add in, right? So that you mentioned the API, and you also have Superbase, you also have Convex. Something that's interesting is like, so obviously I read that and I'm like, okay, so it's like a 3x3 matrix where you just you make as much coding as possible. I think what's weird here is also the missing part is the scaffold that people use.
Okay.
And different scaffolds will lead to different results.
Yeah. I mean, and I think like in both, like for this study, I think like scoping out a lot was like, I think one of the, just, in terms of like trying to get to the interesting parts, I think like same way of like kind of starting with the front end app fully fleshed out. I did kind of, to your point, like I kind of assumed that a lot of these like full stack, but like autonomous coding tasks are going to start from some form of template, right? Like, there's, in that, like these tasks they don't test the agent's ability to, initialize a new next app, wire up auth and configure everything. And it's a fair kind of point that like actually being able to do fully flexible autonomous coding is going to require just like grabbing things from all different types of frameworks. But for here, just to like kind of focus on the like writing the back end and connecting it to the front end and handling state management, those were the types of things I wanted to test with this. But yeah, it's it's focused on that and not entirely general with the full problem of getting everything wired up for sure.
Fair enough. So what were your results? What's interesting?
Yeah. So I think like, the thing that's the kind of way that we measure performance here is that, we put a time limit on each, for each element of the 3x3 matrix. And for the first 2 tasks, we set 30 minutes and then 60 minutes for the files task. And then along the way, this is, currently still really manual because I think it's kind of, it's still, we're not exactly sure how to do evals for this like thing where the human needs to be in the loop. So along the way, I am, giving it hints if needed, if the cursor composer gets stuck and gets into loops. And then I'm also, if it thinks it's done, I'm going and like trying the app and starting grading and then reporting any errors that, show up in the browser and aren't immediately visible. So I think, then this is the kind of quantitative data. Oh, and then the final step, is that once either the time limit is done or the model stops making progress and then we grade it. So we say for each particular task, there's like, if you have a chat app, like does posting a message work? Does posting a message work and live update on the page without a page refresh? If you navigate to another channel, does it show that channel's messages? So we have kind of some predetermined rubrics for each one. And yeah, I mean, I think the interesting results are that, like there's a few reasons for this that we'll dig into. We did notice that, with Convex, it pretty much autonomously just solves the first 2 tasks. It has a few round trips on like some errors that are only show up when playing with the front end. And then it's able to complete this files task and kind of get to close to a full grade within the 60 minutes, where on the other two, the model got pretty lost and ended up not making any progress. And, other than like this kind of validating some hypotheses that we had when we were building Convex, I think there's some pretty interesting observations from the video of like what made the model work and what didn't. That should be pretty general for AI coding in general.
And a quick question on the hints. How do you do hints? I feel like if the model has been working for like 40 minutes, how do you catch up to where the model is? This is something I'm running more and more into when I use the cursor agent. It's like, I just let it go and then it's like, it doesn't work, but like, I don't even know what it did this whole time.
Totally.
What's that flow?
Yeah, it's, this is why, I'll just, in terms of transparency, right? Like why I cut off the first two tasks at 30 minutes is that it just takes a lot of human time to like, I can't just let it run in the background because I'm trying to administer this test as fairly as possible, right? And so like making sure that I'm giving good hints for all three of the backends and all three of the tasks. And yeah, like it is just, noticing that the model's getting into a loop. So even though it might think it's making progress, like noticing that it got back to a state that it was at before, stopping it, and then doing some debugging and very quickly like seeing like this is the thing that it should do differently. So I actually have some details here on like hints I gave. This like for chat and the Fast API, it was getting really confused about trying to combine some TAN-stack query stuff with the SSE, and like at a certain point I just said like, hey, you should just directly use effect, and here's what it should do. There's like another thing I got confused on where I noticed that it was like double stripping the data colon prefix for it, and it just couldn't figure it out. It kept on like alternating between the two. So yeah, I think this is like part of the, for like the meta discussion. I think this type of like mostly autonomous coding is just kind of hard to do great evals for. And I'd be curious if like there are other more automated approaches that folks have taken. Like one idea would be to have a much stronger, like reasoning model that has private access to the solution, and then have that, administer the hints. But there's not a super satisfying answer quite yet.
Yeah, I'm not aware of one. Go ahead.
I was going to say, do you have a sense of how people can then take these hints and try to work them back into the model, maybe put it in the cursor rules? Any research you've done on that side?
That's a really good question. I think the main angle I was thinking of is like looking at these hints, and there's some kind of like stuff in the observation section on what things the model got stuck on and what that implies for like what makes something easy to generate. Like one example where Convex didn't do super well is this hint at 48 minutes. Convex had like a pretty subtle distinction between null and undefined, like just similar to JavaScript. And we noticed that like, because this is a subtle thing that's unexpected, it was the model got stuck on it and couldn't even figure it out. And so this is something where I had to explicitly tell it like, hey, as a Convex expert, this is the thing that you are running into. So, from a platform perspective, like I would, if we can do it in a way that's backwards compatible, I would love to tweak Convex to just match the model's expectations here. But another approach would be to tweak the guidelines that we prompt it with for sure.
Yeah, I found that works with RSpec in Rails. Like the models always want to use like the shoulda matchers, but like, you really should not be doing it. And putting in the cursor rules work, but at some point the model should learn that they shouldn't use it.
Yeah.
Yeah. So, I think this is interesting. How do you compare it versus the other benchmarks that you see out there, like the Sujay-Bench? And then, more recently, now people are starting to compare benchmarks with the actual money making projects like Sujay-Lancer, something that OpenAI recently released. Yeah, just any thoughts on the meta game of benchmarking?
Yeah, I mean, I think like this is, I guess like in terms of experimental design, right? Like the Sujay-Bench category of like starting from real GitHub data and like working towards that does feel like a really nice like end-to-end test. It's almost kind of like in my mind, feels like the same type of test as like an integration test. This test is definitely a lot more targeted, right? It's like saying for this very specific skill of taking a front end app and taking a specification of it, can a agent then perform in this way that is easy to grade, right? It's like easy to say that given a front end app and given a back end implementation, like just, test the functionality that it works, because then also the front end is kept standard, right? So I think the loss of generality here is, in my mind, it's the trade-off is that versus power to grade, right? Like here we can have without having a gold standard of what the answer should be, we still can evaluate the solutions quite effectively, right? So I think exploring different points on that trade-off space of generality versus focused and easy to grade is something that we're pretty interested in. We have another suite of evals for, we just call them Convex evals, that are more coding, kind of small units of code focused, and they're just testing convex knowledge. And that's kind of been another thing that we've observed there, is that we keep the test very focused in a way such that they're extremely easy to automatically test. And then so we can get pretty precise information on, does the model understand a particular concept in convex? And in a way that if we're kind of doing more of the LLM as judge or type approach, and we will need to do some more of that too in the future, but we started with things being pretty focused.
Awesome. Do you see for convex evals, which is sounds like just human eval for convex?
Yep. Yeah, exactly.
Yeah.
Yeah. And it's kind of interesting the numbers are going up the purpose of the convex evals is that we wanted to optimize cursor rules for convex. And so the kind of feedback loop we have is that we have, we test on a few models, and then we add new, quiz questions, right? We add new tasks over time. And then we optimize the cursor rules equivalents to get performance to continue to increase. I think one thing that has been interesting is that we haven't seen model improvements necessarily show up in our convex evals improvement. For example, we just tried Claude 3.7 and it performs worse than Claude 3.5 on convex evals with the same prompting. I think this is we still have to debug exactly what's going on. A lot of the point for our cursor rule stuff is to fill knowledge gaps for the things that the model will hallucinate. And so it's possible that 3.7 just hallucinates different things than 3.5 does. But it hasn't just been a magic bullet. And that's, I think, in itself been pretty interesting. Same holds with O3. O3 does do better than 4.0. We use Brain Trust for tracking all this quantitatively, but I can't remember off the top of my head. But it's not a slam dunk.
Any last questions?
Any goals for the next version of this? Any stuff that you want to add, stuff that you missed?
Yeah, I think one of the things I'm kind of excited about would be, and this is, I think this would be more research. So I'm not, in terms of how, I'm not sure if it'll work or not, but, I have some discussion of this, in future work. I think this theme of gradability is something I'm pretty interested in for if we give the model the task of filling out an API description. And this could be implement the API server for a key value store. There's a lot of room to do automatic verification of that. I think I've wired up a version of this, using L, which is the model checker from Jepsen. And, can a model write highly correct, code that executes under very high concurrency, even when there's, there's some pretty non-trivial requirements. So if it's writing a key value store and it's using, say, MySQL under the hood, but then it wants to use Redis on the side for caching, can it still be serializable? And that is something then that we can grade automatically, and we can give a score as feedback, right? Using tools like Jepsen. And I think the other kind of in this same theme of turning grading into something that can be quantitative and automatic, I'm pretty interested in doing the same for throughput. If we have an open loop benchmark as part of our testing harness, if we have the model implement a simple like key value store, its score can be how much load that can take, how many requests per second it can satisfy on some read-write ratio before congestion collapse happens. So it's kind of like taking some of the ideas from TPC for evaluating databases and then turning that into this form of grading we can use for models. And that's I think one thing I'm pretty excited about. And I think that like pair of having very strong correctness testing and trying to push things to be as fast as possible will like kind of elicit a lot of the difficulties of doing systems engineering.
Oh, Alessio has to jump. I'll go transition us to part 2 of the chat, which is more just mud. Like, I think we're talking about, and if you don't have anything to speak, we can stop it as well. But it's more just about like I guess running Convex in the age of AI, right? Like I think this is something that you were saying in the pre-chat about building developer tooling in general.
Yeah, totally. So we've been at Convex since 2021. And, along the time, we've like, especially because we're kind of in this like think from first principles, like redesign things that have been the same for a while. We've, thought a lot about ergonomics for humans and like what helps people who may not have a lot of backend experience write really effective Convex code. And I think, in the past year and certainly in the past few months, it's just been very apparent that, people are writing code really differently. And, if someone's a dev tool startup and they're writing something that is like in some set of APIs or systems that are targets for AI coding, it's silly not to strongly consider how AI coders perform on one's platform. So that was like the, motivation for kind of investing in making some of this analysis a bit more rigorous. And then also, users kept on telling us, they're like, hey, like Convex works really well for this, but I noticed that there's some knowledge gaps and there's like these consistent hallucinations. And I think shaping one's platform to be a great coding target is like, something that's just table stakes in 2025.
Have you made any, you said shaping one's platform to be a great coding target. I think a lot of people have basically tended to take their perspective on developer experience and just go and just crafted it onto this new thing that people are calling for agent experience and say like, oh yeah, like, because we emphasize developer experience so much and obviously Convex does, then that also translates well to LLM's coding. But has anything changed for you? Has it influenced your design of Convex in any way?
We haven't shipped any of these ideas yet. Some stuff where it's like, we have some ideas for V2s of our API. And I think one of the cool things about now having the eval set kind of written out is that we can do like synthetic user studies, right? It's like easy to just like make a change and then just test it, right? And see like, does it match the LLM's hallucination? I mean, I think one thing that's kind of interesting given these, models' inherent internal structure is that we notice that a lot of hallucinations come from parts of our API that are like very close to Firebase, but not exactly Firebase. And I think these are things that like a human wouldn't, be as susceptible to. But then like, especially when Convex is not that represented in the pre-training set, like it's, it was one of those things that when our customers actually gave us that hypothesis and it just all kind of clicked. So I think that's where, walking in with the assumption that good DX implies good AX or whatever we're calling it, like, that can be kind of limiting. And I think it's like, writing a great eval set is just a lot, it's a pain in the butt. It's a lot of work, but I think it's just kind of hard to substitute that.
In some ways, I mean, that's annoying about the Firebase thing. So is your intention to move further away from Firebase or move closer to?
Yeah. I think we're gonna have to try both, right? And we'll see. I think.
Okay. Like one tricky thing I feel like is almost like AI calcifies your API. The cost of switching APIs is so high because you don't know what the hell is in the data set. You're not gonna reach out to every model lab and like ask them to update the data set. It's almost like you can't change it. Like whatever existed pre-AI was like you're locked into it. I don't know.
Yeah. I mean, yeah, it is a little depressing, right? I know people talk about this, like, kind of, in terms of, even in terms of like the knowledge cutoffs are really far in the past, right? Yeah. I mean, I think
that's a real concern now because they're updating every few months, but it's still, the bulk of the data is still old.
Yep.
Yeah.
And I mean, I was pretty depressed is too strong, but I was pretty pessimistic about this before we did the kind of evals work. It has been pretty cool to see like how steerable the models are in that, with like and we have to do a little bit more work on like token efficiency. Like how can we get our evals to pass at a high rate with as few like tokens in the crystal rolls as possible? Because we've noticed like kind of really long, if we've made it really long, we've noticed model performance getting worse on like very complex tasks. I think, and this is, above my pay grade on how it knows to attend to particular parts or not. But that's like, I think one kind of interesting trade-off, like optimization problem. Yeah. And, I think it's, from the aesthetics of API design, this is like, just certificating, right? Maybe this will, if we are things that are non-standard and things that don't match whatever in some. And I think that's maybe not so.
Yeah, awesome. I have a slightly different question if you don't mind, unless you have anything else to mention on this design topic. I think one of the other big impacts that Convex had in the AI engineering world that I saw that hit my consciousness at least was AI Town, which the A16Z guys, super value add investors, up with you guys. And I think more generally, there has been a lack of follow through on that kind of agent work that I've seen. Like very cool demo. People loved seeing it. Like then they're not like, okay, but how do I use this? So basically, I think my question is like, how does Convex see like the back end, like being the back end of agents? Do you have everything you need? Are you just waiting for the market to catch up? Or like where are we in that cycle?
Yeah, I think it's a very interesting, like strategic question, right? In that as a backend platform, I think when we were really starting to dig into like, this particular round of AI investment from us, like, I think it felt like that there's kind of two paths in the decision tree. There was like people using AI coding to write backends that are like kind of the same as they were before. There's like, there's like the hypothesis there being that there's all this pent up demand for apps that maybe aren't so different than apps a year ago or 2 years ago. And that like a much larger set of people can do it at a much smaller cost. And then there's the other side of like, will backend infrastructure look different with all the changes in AI? So 2 years ago, that was like vector databases, right? Which like, were used before, but now are just so ubiquitous in a way that weren't. And there's like I wish I remembered off the top of my head. There's a really good blog post on agent architectures around like, using temporal, right? And like using, like the usual techniques for making like a unreliable service and adding retries and extension backoffs and all of that. I think like, yeah, we're very interested. I mean, we have like a workflow system on Convex, like for durable execution. And I think we're still like investing more on that first category of like saying like, how do we take the usual shape of apps on Convex and just make it very easy to AI generate? And then kind of getting that in a really good place before investing more on these like the new shape of apps. But yeah, like I imagine like that those types of patterns of like durable execution, like being able to have very close proximity to all the data sources and being able to query your data once database and in vector stores and all that. But it's something we are excited to invest in. Haven't gone around to it yet.
Yeah, I would say a lot of people are still figuring out the patterns. Like, as hyped as the Anthropic blog post is on agent architectures, actually most of it is like explaining what is not an agent.
Yeah.
So I think we still need to map it out as well. Cool. Any other parting thoughts on just Convex's general AI strategy?
Yeah. I mean, I think the, this is like kind of the takeaways from the Fullstack-Bench thing, but I think they're pretty broadly applicable. I think like, just like for human coders, I think, this is a place where DX and AX, line up a bit. It's like, having just really tight feedback loops and having strong guardrails. Like in Convex, that's like end-to-end type safety, but that's like, could take it in many, many different forms, right? Like making it so code is very cheap and easy to grade. Making it so that, one other thing we observed is that just having more represented in code, and like it's kind of like our conversation about stuff being in the pre-training set or not, like having things just be standard and procedural code and not doing kind of weird, crazy stuff.
Yes. It's another
strong, just like,
yeah,
totally. And we even noticed like, reasoning kind of being one also big separation, like reasoning about procedural code when debugging is like something we notice models doing pretty well. The particular example was like RLS rules and Supabase, where debugging like an infinite loop for infinite recursion for the RLS rules was something that the models just really struggled with in a way that we didn't see for procedural code. So that's another kind of interesting thing, but that shows up in a lot of domains, right? And I think, the final kind of observation from that article was just that like strong abstractions are good, like models, when given the full flexibility of fast API and doing SSE and wiring everything from scratch, it just couldn't help but mess it up. So having like kind of strong like choosing good libraries that have strong abstractions is like, always a good bet with models. And that's, hopefully also something that's pretty general.
Yeah, I think that's a good message for tool builders out there anyway. So like, also, well, thank you so much for sharing and jumping on, and, congrats. I look forward to seeing more Convex's, progress over the coming years.
All right. Thanks for having me.
Thank you. All right. I'll stop.